also okay into the residential and commercial as well as industrial solar solutions. We install different we run an academy, the Gen X Solar Academy, where we train individuals on how to become knowledgeable and also experience in the installation of solar systems. So right now we're going into the training, and our facilitator will be taking us from.
Good morning, everybody. Like we've been informed on the topics we are going to treat this morning. You are all welcome. So Gen X low voltage inverters are hybrid inverters with MPPT operating voltage range, typically between 60 volts to 115 volts DC. But the maximum rated voltage is 145. You are advised not to operate at that maximum, to be safe. Gen X low voltage inverter models include Expert King, MKS 0, then Power B. The Expert King, like some of us are familiar with these models. The King works like a UPS, is an online inverter. MKS 02 has zero transfer time, while Power B is the line interactive that switches within a few seconds, microseconds, and you just don't notice that transfer time. But for the first two, they are zero transfer models. Installation guide for Gen X low voltage inverters. These are the guides that you need to observe, and very important because if installation is not well done or is not properly done, then you expect wrong response results from the damage and malfunction and anything. All solar panels should face, through south, for northern should face south, so that when it's all through till sunset, so that you capture enough generation, enough energy from the sun. All solar panels in a string must be on the same flat roof platform or face the same direction. This is also important so that you don't put a lot of solar panels on the roof, yet they are not generating enough or the expected. So if they face where they should face, they generate better. You get a better experience. Because if one of them is facing one direction and they are all in string, and the direction that one is facing is making it to generate low, then it will condition all the other panels that are connected in series with it to generate that same wattage. For instance, you have 400 watts and only see 200 watt to generate 200 watts. So you'll be losing a lot of energy. So please, this is very important. Connect each string of solar panels for each inverter directly to each particular inverter for a three-phase synchronous system. That is, when you are cascading this inverter, you want to use like 3 to generate 3-phase, like a 3-phase generator. So when you connect them like that, the solar panels must not be connected to a bus bar, because if they are on a single phase, you can do that. Just get your positive bus bar, negative for bus bar, then you connect all panels positive terminal, you connect them to the bar. Then you connect all negative cables to the negative. In a way to generate 3 inverter must be connected to a group of panel, and you cannot bring all of them together. There will be conflict. So that is also important. Open circuit voltage VOC of PV array should not be more than 100 volts. It's an advice, so that you won't have to be thinking, or maybe when something happened, oh, it's because I am operating at the maximum. So it's better to operate below that maximum. So in essence, you are connecting 2 panels together. That's what the input and output neutral terminal must be looped at the connecting terminal of the inverter. This is also important. By that, you are connecting the system to operate on a single neutral system, not you connecting input line, live and neutral separately. Then you now connect output, live and neutral separately. No, the that comes there serves as the neutral for both input and output. It serves as a projection for the system, in case there is a reverse polarity from the pole or top. The inverter may still be working, but then it will still give you the 220 without getting the system damaged. Must be connected to a good earthing is okay, so that there is a fault in the building, and then you're to the operators or the people that are operating. Do not power on the inverter before you start configuring the settings. You know, the inverters are programmable, so that you don't damage your batteries or get a wrong performance from the inverter. You have to program according to the specifications of other components, like the battery that you are connecting to it. For instance, you have a battery that is 200 amp hour and you are connecting 4 in series, and it's stated that for each of the batteries you have to charge with 20 amps. Then you need to program the inverter charging current to 30 amps. The bulk charging voltage has its own number there. Then you have to go there in the settings installation and confirm and configure on the inverter before you do this configuration. It's very important. Just use your solar. If solar is available, switch on the solar. Then the inverter will start charging. Then you go to you enter the program, then you program everything. Reconfigure the inverter before commissioning. Whether your inverter has gone for for repair, or whether it has gone for repair or is a new system. Before commissioning, you have to go through the program and then make sure the settings inside are correct. You may be relocating the inverter, for a reason, and you have already programmed it for the one that's there. So you can all that may not be, the setup may not be exactly the same. Do not action to avoid damage to the stick by connecting it up from the inverter to negative terminal of the battery. Same thing is applicable to the solar cables. So make sure that the polarities are correct. Ensure that
Everyone. Sorry, we're trying to sort the network issue now. Just give us about 2 minutes so that you'll be able to hear the facilitator. Just give us about 2 minutes and we'll come back. Please stay on the call. Thank you.
So sorry about the break in transmission. Okay, like I said, ensure that lightning arrestor is installed when you install solar panels, or if it's already installed on before you start your installation, then terminate the frame of the panels to it. So that's about that. All solar input must be confirmed not leaking. It may be leaking to ground or other, for instance, after installation, the frame of the rail are allowed to rest on cables and press them against the roofing sheets. There could be leakage. We are talking of high voltage here. When the system is high voltage, even when it's low voltage, the same thing is applicable. So just ensure that there is no leakage by carrying out a PV test on the input solar connection. Be sure that the connections are correct and intact. After installation, you check all your terminals and breakers, polarities, and everything before you start switching on breakers and everything. So That's the installation guide, control, stroke protective devices for Genex low voltage inverters. One input breaker, which is one pole. Most of our breaker for this model of inverter is one pole. So you have one for input, one for output. They are single pole. One utility, which is AC surge protector. One for the input, then one for solar, depending on how many strings of solar panels you have. You also need a protector for PV, which is a DC surge protector. Then you have one solar breaker, a DC one pole. Then you have two pole, because it's not so easy to get 125 amp, 250 amps breaker for a 5 kVA inverter. So you can loop one two pole 125 amps breaker to achieve your 250 and perfectly. So then you need a bypass switch to make the system transfer from direct to inverter smooth. Your client can do that. If there's any issue, he can easily flip to direct, which is bypassing the inverter until this problem is sorted out. So Genex high voltage inverters. Genex high voltage inverters are hybrid inverters with MPPT operating voltage range, typically between 120 volts and 450 volts DC. But the maximum open circuit voltage is given to be 500 volts, which we don't always encourage anybody to operate around the value. Genex high voltage inverters models include MKS3, for some of us that are familiar with, VM3, Aspac Mags, Twin. Then we have Infinisolar. Infinisolar is the bigger one, 10 kilowatts, 3-phase, while others are single phase. But we all know that we can connect any of these inverters that are parallelable, like the VMAX Twin is parallelable, so you can connect it to make your 3-phase, depending on how you want the design. So installation guide for Genex high voltage inverter. All solar panels should face the same direction, through south for northern hemisphere. That's talking about Nigeria. It's better to allow them face south so that the movement of the sun from the left to the right will be captured. All solar panels in a string must be on same flat roof platform or face same direction so that they can generate equally. That's just what that means. Connect each string of solar panels for each inverter directly each particular inverter. This is applicable to all high voltage inverters. You don't connect solar panels and then you connect all of them to a bus bar and you now start sharing for each inverter. It's not acceptable, and it could damage the inverter. So please don't go near that. Open circuit voltage VOC of PV array should be about 300 volts DC, 400 volts DC. You are advised to operate at that high voltage. The higher the voltage within the normal range, the better and the performance and the experience you get from this system. Solar breaker must be double pole high voltage DC for PV. You know, this high voltage, you need to cut off both positive and negative when you switch off the PV. It's very important. And the breaker has to be high voltage. See, it's the normal rating. You don't have to experience hacking or where a breaker catches fire because you're not using the right side. The input and output neutral terminal, like I mentioned earlier on, must be looped together at the connecting terminal of inverter. This is applicable to all our inverters. The inverter must be connected to a good earthing system. Do not power on the inverter before carrying your configuration operation. That you want to set, you want to program the inverter according to the setup. You don't need to power on the inverter. Just use your utility or solar. If solar is available, on only of the breakers according to a sequence. Do not reverse polarity of connection to avoid damage to the system. Ensure that lightning arrestor is installed alongside the solar panel installation, which is very important. All solar inputs must be confirmed. You have to carry out a solar test to be sure that there's no leakage. If there's leakage, the inverter can start misbehaving and it can even damage the MPPT or other components inside the inverter. So be sure there's no leakage between earth or any terminal, either positive or negative of the inverter. Be sure that connections are correct. Installation guide, control protective device for Genex high voltage inverters includes the lists below. 1 input breaker, 1 output breaker. These are single poles, not double pole. You are advised to use single pole. Neutral normally should go direct to a common terminal. Don't use double pole to make the installation simple and trouble-free. Then 1 utility AC surge protector, then a solar breaker, which is high voltage from 500 volts to 1000 volts. DC 2-pole breaker is recommended. 1 solar DC surge protector, depending on the number of inverters and the solar inputs you have. 1 battery breaker, which is double pole because you need a high current, so 250 amps thereabouts. So you need to loop the breaker together. A bypass switch to allow your customer to be able to bypass the inverter if there is any issue or during troubleshooting or anything, so the person can go back to direct. Inverter commissioning now. This is the procedure. It's also very important. So the battery breaker, that is the first thing you do. Of course, as you are installation, all your breakers should be in off state. So when you now want to start commissioning, then you start from the battery breaker. So the battery breaker, after you must have confirmed your installation is okay, then switch on solar breaker, which is the next one. When you switch on solar breaker, inverter wakes up and it displays on the screen and it will immediately start charging. If solar is not available, switch on your utility, which could be your generator or public supply. Immediately you do that, the inverter wakes up and starts charging. Reconfigure the settings. You know, here now we have not switched on the inverter. You have to reconfigure before you power on the inverter. First of all, reconfigure all the configurations, change the one that you need to change and make sure that it follows the specifications of components like. So after doing that, then you can now switch on the power button on the inverter. Be sure there is no error code. Switch on the output of the load breaker or the load breaker, Then switch the bypass control to inverter, because you will have labeled your bypass control one side of it as bypass, the other side inverter. If it is on bypass, even when the inverter is on, you won't get any output to power the building. So it has to be switched to the inverter side. Your bypass switch is like a change between direct and output of the inverter decommissioning. When you want to decommission now, that's to shut down the system. There is also a sequence you follow. Switch on the bypass control to bypass, because you want the owner to be able, now that you want to remove the inverter, you want the owner to be able to operate on NEPA generator. You may not be removing the inverter. Probably you want to carry out some troubleshooting and you don't want this for the client. You do that so that while you are doing your troubleshooting, the clients can be on direct supply utility. So switch on the output or load breaker. I mean, you switch it off. Then you switch off the solar breaker, you switch off the utility. Yep. Sorry for that short break in transmission. So these are the common commissioning and decommissioning
right. So sincere apologies for the. We'll be continuing now. We'll be rounding up soon so that we can take questions right away.
Yeah, I was talking about improper login or choice of, or no, I'm talking about wrong choice of cable size and quality. You have cable quality, if the cable is correct size and is a wrong quality, then there will be loss of power. The cable will be eating, can lead to fire, it can lead to anything, hacking, it can damage the terminal of the inverter, it can damage circuit breakers because there will be hacking at the terminal of circuit. So a lot of things. The best thing is to get things done and get the right components. Wrong rating of breakers too will just cause a kind of nuisance. You can just be tripping off. If it's lower, if it's higher than necessary, it won't even trip. It will allow the heavy current to go into the inverter and damage the system. So it's good to choose carefully. According to calculation, there are calculations to all this. Wrong, PV module, stroke mounting rails, pressing solar cables against the roofing sheets I mentioned earlier on. We introduce a leakage to a high voltage system. It may not even cut the cable. Based on experience, it may not cut this. There is insulation on the body, but because it's pressing it, there will be a transfer of this thing. There will be leakage, and then the inverter could respond to this. So terminal not properly tightened, there will be hacking, like battery terminal or terminal of circuit breakers, terminal of inverter itself, like input battery terminals of inverter or solar input. All these terminals are very important to be well tightened to avoid malfunction or misbehavior. It could be damaging the system. It can just turn to a poor power quality. Meanwhile, is the quality of power coming from the grid is okay, but when it gets to where the inverters are installed, because of all these little errors, it will be causing damages and misbehavior from the inverters. So reverse polarity of connections, that will lead to instant damage of the system. So do not on or off battery breaker when system is in operation, whether the system is batteryless or the one that has to operate on battery. If you want to change from battery to batteryless, shut down the system. You know that it is deliberate. I want to operate on batteryless now, then I have to shut down and off the battery breaker, then you start it again. You are operating on batteryless, not just anybody going to off or on battery breaker anyhow. It could lead to a malfunction of the inverter and it could even get it damaged. So reverse polarity of connections, is not acceptable. Do not set UPS mode while using generator. UPS mode on the inverter will narrow down the range of operation of the inverter. So it will be operating, it could be 220 to 230, something or something like that. So when there's a little bit switch down below that value, the inverter will be switching up and down, trying to maintain a balance. But if you choose the appliance mode, that one gives you a wide input range, like from 170 to about 275 or so. So that's will give you, a wide operating range, and then there won't be any disturbance. Wrong commissioning procedure or sequence can damage the inverter. So it is important to follow instruction. And you can read more from the manual, ask questions from the people in charge. I think all these are very important, and we have learned one or two things, and we'll be reminded of what we learned in the past. Thank you very much.
All right, so thank you everyone for joining. I'm sure that was an enriching session, and we apologize once again for the technical difficulties. So we would like to take questions now. So if you have any questions, please type in the comment section, the chat session, and we'll also be taking questions from 1 to 2 people who can speak up. So you can also raise your hands if you have questions so that we can take a question. So we just have about 10-15 minutes thereabout to take questions. Thank you. Okay, so any questions? Any questions? Can speak up or type your questions in the comment section.
Hello, good morning.
For
Everyone.
those asking, yes, the presentation will be made available. We'll send that to you to your emails, as well as the recording. We'll put that on our YouTube pages and website, so it will be uploaded for you to check at any time. Also share the presentation with you via mail. All right, so we have a question here in the comment section. It said, is it okay to add external charge controller MPPT to existing GenX high voltage hybrid system to charge the battery bank? High voltage hybrid inverter is 120 volts to 450 volts. Can I add external solar charge controller of 145 volts MPPT to the battery bank? So I'll let our facilitator take to answer that question right away.
Okay, it's not always advisable to use external charge controller on hybrid system because it will definitely lead to poor battery management. But if you are sure of the capacity of the battery, probably you have a large bank or you have lithium ions that can take very high current than what the utility and solar available within the inverter can provide, then you can go ahead, add external charge controller. Probably you have a large bank of battery and then your load is not much, because if you have a bigger load size of load too, you will need a bigger inverter that you won't even need to say you want to use external charge controller. Well, I think that's clear enough.
Okay, so we have another question here. So it says, setting the program 2 and program 11. Sorry. Will this add the 2 currents to charge the batteries, or will only pick program 2 even if grid is available?
Well, setting program 2 and 11 to same value or charging current. If you set whatever it is set in program 2, it is what is allowed to go into your battery. Whatever value you set in program 2 is what is allowed to go into your battery. For instance, you set program 11. Program 11 operates only with utility. So if you set program 11 to 20 amps and you set program 2 to 20 amps, at every point in time, what is allowed to go into your battery is 20 amps. That is, when utility is available and when solar is available, only 20 amps will go to your battery. When only utility is available, the 20 amps you set in program 11 will transfer to program 2 and it will go out to your battery. But if you want combination of the two, then that means you set program 2 very high. For instance, you can set program 11 to 20 amps and now set program 2 to 40 amps. So when utility only is available, 20 amps will go to your battery. But when utility and solar are available, it will now be what you set in program 2. If it is 40 or 50 that you set it, because it will combine the two now. It will first of all take the old solar energy and add a utility to it and push it out to your battery.
All right, thank you, sir, for that explanation. I hope it's clear. Please let us know. Okay, so we have another question here from Mr. Oluseyi. He said the high voltage hybrid inverter is stated to work between 120 volts and 450 volts. Why is it then that the inverter will not work with solar array of 135 volts VOC?
Yeah, it's very close. At that time, when your solar is generating that voltage as VOC, there is no energy. If you subtract that peak voltage of the solar, you subtract the minimum of the operating range from that peak, the value you get is small. Like I was saying, the from the lower point of operation of the inverter, the higher the energy you'll be able to get from it. It's very voltage is high, you see that you get enough energy, you get a lot of power. Now, maybe it's now you 500, if it's high, a lot of energy from So
we wrap up shortly. So is parallel connection acceptable in high voltage inverter? Like I have 300 watts of 16 unit series connection, series with a TD input voltage. Can parallel connection 8 in series into 2 string? Is it okay to parallel for high voltage hybrid inverter to get good results?
yes, you can parallel panels for high voltage inverter, but then you ensure that it does not exceed the VOC specified by the manufacturer for the inverter. For instance, if the VOC of the inverter is just 20 volts, and then you are now paralleling, you are getting 20 something as VOC of the two strings. I mean that we're talking of current. Sorry, when you parallel, it is the current, not the VOC as mentioned in the question. The current goes high, so the current must not exceed the input rating of the inverter. It could be 20 amps, and then you are not putting the current of the parallel arrangement is now giving you maybe 20 at the amps. Dangerous when you have every load on the
Wrap up. Today, please explain to us what kind of MPPT can we use for 30 kVA 3.
The directly clear 30 kVA. If you want to use 55 kVA to inverter has its own MPPT charge controller. That means you want to take your panels, you segment them. But if you want to use the same part, than other 55 kVA because of its own capacity you are looking at to get from the system. They all have internal MPPT charge controller. I think that answers your question.
All right, so would that's all we're taking for today. Thank you once again for joining in, and for further questions, you can always reach out to us via social media platforms and our contact details on our website. We'll also be sharing the presentation slides to our emails to all registered participants, as well as the videos will be uploaded on our YouTube and website page. So would love to see you for our next training. We hope that you learned a couple of things in this training, this webinar. And like I said earlier, further questions are welcome. We're always happy to attend to you and help you get more clarifications regarding any installations of GenX inverters. All right, thank you very much again. We apologize once again for the technical difficulties. Thank you and have a great day.